Okay, our next topic, the nice thing about this course is that we've gone through all these topics in simple interest so far, so now we're just applying a new formula to them, so we can actually go quite a bit quicker refreshing on these and then expand on to other types of investments and situations. So that's why we're going through so much of it fairly quickly compared to the first unit, because you already have that groundwork laid for you. Let's talk about calculating the present value. So remember, we also called this discounting a payment, because remember, for our purposes, most of these questions, especially if we're talking about money, we're talking about a positive interest rate. So you invest $1,000, you get back $1,100. You're always going to get back more money. In the future value is going to be greater than the present value. So present value is less than the future value. The only time this doesn't apply, like I say, is for certain situations like you could, for biological situations and things. Like I say, we have an example that'll come up about a species of frog that catches a disease, and so they die off each year. Well, that would be a negative interest rate. But for our purposes, because of inflation, the value, it costs more money in the future to buy the same thing as it would have today, on average, not necessarily on electronics or something, but say on food and things. Money in general, you want, if you invest, yes, short-term things can sometimes have a negative interest rate, but in general, money is always increasing into the future. We're assuming you're investing in something that grows over time. So we have our equation, future value equals present value times bracket 1 plus I bracket to the power of n. Let's solve for the present value. How do we do that? We want to get present value all on its own. So we're going to take this guy and divide it to the other side. So let's flip it around while we're at it. So present value equals future value divided by bracket 1 plus I bracket to the n. So we just divided this other, that whole expression, whatever number that turns out being, we divided it to the other side. Like we did with simple interest. We divided by the 1 plus RT term. But what's neat here is we already have an exponent involved. You may remember a certain exponent rule. I can't spell today, sorry. Remember, x to the negative 1 is the same as 1 over x. So there was an exponent rule we used to have about if you have something 1 over something, that's the same as that number to a negative exponent. So we can simplify this. So we get instead PV equals FV times bracket 1 plus I bracket to the negative n. Isn't that a lovely formula? It's exactly the same formula, except we've just changed the exponent to negative. So if you're finding the principal, the PV, in the past, then you're going backwards and you're dividing, but that means you just make the exponent negative and now you're going backwards. So time is always positive, but which way you're moving in it is what that exponent is dictating. So from here, negative exponent means going backwards in time, calculating PV. Let's apply this to an actual question. So I'm not going to break up the video this time just for that little bit. Let's do a question right away. Amy invests some money at 3% compounded quarterly for 3 years. So, how much should she invest if she wants to end up with $5,000? Okay, so we're trying to solve for PV. So, let me just, okay, so the future value is $5,000. Sure, our nominal, so J, our nominal rate of interest is 3% compounded monthly, or quarterly, sorry, quarterly. So then I is going to be 3% divided by 4 for our purposes. And we said 3 years, so N is going to be 4 times 3 years. N is going to be 12 compounding periods. So we're going backwards in time 3 years to figure out how much money would she need to invest to end up with $5,000. Let's try our new formula. So PV equals FV bracket times bracket 1 plus I bracket to the negative N. So yeah, it's great because it's the same formula, it's just the one change of the exponent makes it flip PV and FV. So it's fine. So PV equals, so that's 5,000 times bracket 1 plus 0.03 divided by 4. There's our periodic rate, bracket, to the power of negative 12. I'm going to go one more line here. So that's PV equals 5,000 times, because there's a little trick here. So that's going to be 1.0075 to the power of negative 12. So yeah, walk through this with me, okay? Give me the benefit here. So I want to make sure you can do this or get that far. So how did I get there? So working our way outwards from inside the brackets. 0.03 divided by 4 equals 0.0075. Plus 1 equals 1.0075. Now, how do we do to the power of negative 12? There's a slight trick here. You can't, so you still hit the exponent button, y to the x, but then you actually have to say it backwards. You have to put the number 12 in, 12, and then hit this plus minus button to make it a negative 12. And now you can hit equals 0.914. Again, we're looking for a number less than 1 because we're dividing now. Well, because we would be dividing, or we're multiplying by some smaller factor to discount it, to have a smaller amount of money. And then times 5,000 equals. So let me show, so like I said, here I said 1.0075, hit my exponent button, y to the x, then I typed in 12, then I hit the plus minus button to make it negative, and I hit equals, and then I said times 5,000 equals. And so PV is equal to $4,571.19. And just so you can make sure you're following along, let me show that intermediate step. PV was 5,000 times 0.914238,155. Because it's important it's important that you're getting that you're doing these calculations correctly. Honestly, with enough practice, you will know that you're doing it correctly. I mean, I'm sure you can make a mistake on the test anyways, it can happen, but, pardon? Yeah. If you have practiced these questions enough, then you will be familiar with the routine, the way to use the calculator. That's also why you should be really practicing with the calculator early on so that you're familiar with the ins and outs and in case any of these functions work slightly differently than any other calculator you're used to. But yes, so here we figured out that Amy should invest $4,571.19 for 3 years at 3% interest compounded quarterly if she wants to end up at the end of that time period with $5,000 in her account. We've discounted the payment. Like I said, we went backwards and we found that, if you want to end up at $5,000, you need to invest less than that because it'll have time then to earn interest. And remember, if we ever refer to the discount rate, that is just the interest rate we talked about. So 3% compounded quarterly is the discount rate. It was invested for 12 compounding periods because it was compounding 4 times per year and we invested for 3 years. So our exponent would have been 12 if we were calculating forwards in the calculation, but negative 12 because we went backwards to find PV. Okay, so yep, super handy, and it's nice because that's the only difference is just that plus minus button down beside the decimal point. Here everything else is kind of the same as if you'd been going forwards with the calculation, except boom, make it negative instead, and now you're calculating a PV instead of an FV.